Our next section is going to take an advanced step into systems of equations. Most everything you've done up to this point in this chapter is a review of Algebra 1, what we did with systems of equations by graphing, substitution, and elimination. Well, we're going to take that next step now into a three-dimensional world. We're going to talk about three equations and three variables. And when you get into a three-variable equation, there is such a thing as a three-variable graph. If you look at the picture here, you see a graph that has an x, a y, and a z-axis. That's called three-dimensional graphing, and we're not going to get too much into actually drawing that picture because it gets quite complex. But what we're talking about when we have these equations in three variables is we are still trying to find the intersection point between the three equations graphically. So you can see that does still make the visual connection even though we're not actually going to graph three variable equations. We're going to look at the elimination method and substitution method for solving systems in three variables. Here we have an example of a system of equations in three variables. We have an a, a b, and a c variable. Just like when you solve equations in two variables, this system's answer is going to have an a value, a b value, and a c value. You need to have all three to have a complete solution. In order to solve this, we're going to use the elimination method. And the elimination method is exactly the same as it is in two variables. It's just going to require more steps because there's three variables. So in this case, we want to look and see what variable is the easiest to eliminate. A, B, and C, which one would require the most work to make them the same? And if we look at A, we have a 3, a 2, and a negative 3. So based on our previous information, we should be able to look at those two equations first and say, we can eliminate A very easily in those two equations, like this. So this is where we're going to start. The same elimination we've done with our other problems, leaving us with, that should be negative 4b, I don't know why I wrote that backwards, negative b plus 7c equals 41. So now we have an equation in two variables, and so you may be seeing where this is going. We're going to take a three-variable system and rewrite it in two variables. So now if we take our bottom pair of equations, 2a plus 2b minus 4c equals negative 26, and negative 3a minus 4b plus 2c equals 14, I need to make this into a two-variable equation. A lot of you would naturally look at this and see I have 2 and negative 4 in my b's, and I could cancel out a b. However, that's not going to help me. I have an equation over here in two variables that has b and c in it. So that means I need to eliminate a. So we go through the process of eliminating a from this system of equations. 6a plus 6b minus 12c equals negative 78. We're going to get into some bigger numbers with these three variable systems. We have calculators, bigger numbers should not be an issue. I multiply the bottom equation by 2. And add those together. A's cancel, negative 2b minus 8c equals negative 50. So now I can solve those by looking at these two equations. When I've eliminated A, I now have a system in two variables just like what we've been doing. So we've done all that work to get back to where we started 2 days ago. So now we're having fun. We've done all this work just to get back to what we've done before. So now when we look here at what we have right here, we have a system of equations in two variables. This is what we've been doing up to this point. In order to solve that, we can eliminate the b's by multiplying the top equation by negative 2, making it 2b. Sorry, that should be minus, because it's times a negative 2, minus 14c equals negative 82. We add those two together. Negative 22c equals negative 132. Divide by negative 22. C equals 6. So you see now you need to really understand what you've done previously with elimination in order for this to make sense. So I have C, but I'm not done yet. I need to find A and B. So I'm going to go over there to find B. I can replace C in this equation with 6. Just like what you've done with every other two-variable equation. I could plug 6 into there, which I'm doing, or I could plug 6 in up there. Either one will give the same solution. Negative 2b minus 48 equals negative 50. You add 48 to both sides, and you get negative 2b equals negative 2. Divide by negative 2, b is 1. So I now am 2/3 of the way through my problem. To finish off the last step, we have to go back to the beginning and pick one of these equations. I'll take the top one. 3a plus 3b plus 5c equals 27. 3a plus 3b plus 5c equals 27. We know b and c. We can solve that with simple algebra. 3a plus 33 equals 27. 3a equals negative 6. Divide by 3. A is negative 2. So what that means is, in a three-dimensional graphing setting, we would have an intersection here at the point negative 2, 1, 6. A three-variable system requires a lot of work. None of it is really new. None of the steps we've done, elimination, is new. It's just going to require us to do an extra step. I'm going to quickly walk you through what this would look like with substitution, and then we'll be done. As you can see here, we have the exact same problem, but now we're going to look at it from a substitution method. To do this problem with substitution, I would probably start with my middle equation. I'm going to minus 2b to the other side, add 4c to the other side, and divide by 2. Oops, that needs to divide everything by 2, so that becomes minus 13. Now, I could go back to my other two equations, that one and substitute for A with negative b plus 2c minus 13. That's supposed to be a c. Leaving negative 3b plus 6c minus 39 plus 3b plus 5c equals 27. When I combine my like terms, it becomes, the b's cancel out, making it 11c minus 39 equals 27. Add 39. 11c equals 66. C is 6. You notice we got to that exact same solution we did on the previous page, getting c equals 6. It just happened a lot quicker. I could then substitute 6 in for c in the other two equations and solve that system for A and B. Substitution is normally not quicker. In this case, it did end up being the case, I would suggest using elimination as much as possible. However, I wanted to show you that in case you're a person that really likes substitution, to show you can solve these by substitution the same as elimination. Good luck.